Hi everybody, it's Mr. Bennett here again. We're going to start looking at integration today, and I'm going to start by going through the theory from the fundamental theorem of calculus. So if we look at this over here, that basically says that if you're integrating from A to B, as per the diagram down here, a function of x, f of x, with respect to dx, then the area is going to be bound by this particular thing over here. Now, what I put here is all the rules of different integration for you, and obviously you won't really understand those right now, but what I'd like to say about all of these rules over here is they are the anti-derivatives. So if you think about, obviously when we're doing things like squaring something and we take the square root, this works exactly the same way in terms of if you differentiate something, what we're doing effectively is working backwards and finding the integral of that. So now there's two types of integrals that you'll be working with, is these ones over here, which are called indefinite ones. They don't actually have a particular area that's bound, it's just the process of integrating. And here, the one in the example down here, in terms of looking at that, is a definite integral where that has a definite area, right, defined by that particular value. Now when we're doing this, it's always the top function to the bottom function. In the case this one here, the bottom function is in fact the x-axis. Right, so I'm going to go through a couple of examples for you just to get the idea of how to integrate that, and I'm going to show you also how to do that on the calculator as well. Now if I'm going to integrate that, I'm going to use the first rule up here, which says that x to the n is equal to n plus 1 all over n plus 1 plus c. Now c could be any value, keeping in mind if you have a constant value and you differentiate it, it becomes 0. So now because we've got a definite integral, we don't actually have to put the c value in for this one here. So what I have to do is go x, and I'm increasing the x by 1, so that becomes x to the 2 plus 1 is 3, and that's all over n plus 1, which would be 3. And because we've got a definite integral, we're then going to define that as 3 and 0. So when I start working that out, what I have to do is substitute 3 into that equation, so that becomes equal to 3 cubed all over 3, take 0 cubed all over 3. Now obviously this being a fairly simple example, we could basically know that's 27, the top line divided by 3, that's going to be 9, take 0, so therefore the area bound by that is actually going to be equal to 9. Now if I go to my calculator, I can put that value into my calculator. So I did have x squared, so let's put that in there, x squared. And I'm going to graph that. You can see my function there. I might need to change my window there very quickly. Let's go to 10 and make that go to 10 as well. So if we graph that, you can see that's my x squared. Now there's two ways of working out this area just to check that that's correct. I can come down to number 7. Alright, so if I go to 7, put my lower limit is in fact 0. My upper limit is going to be 3. And that actually works it out and gives me an area of 9. So that actually confirms what we're doing. The alternative way of doing that is to go to your math button, coming down to the fint. Alright, so fint. Alright, so I'm going from 0 to 3. Alright, my function is x squared. And then it's a function of x I'm integrating with respect to, and it gives me a value of 9. So there's two ways of doing that to check our answer is correct. Now let's go down to our next example. Alright, so if I'm going to integrate that, I'm going to first of all write that as 0 to 2 x to the half. Alright, that's the easiest way of thinking about that. So when I integrate that, I'm going to get an answer of, I'm going to add 1 to it, so that's going to become 3 on 2. and then that's going to be 3 on 2 as well, which we can write if we want to as 2x to the 3 on 2 on 2. I'll do that in a second. So that's 2 and 0. So effectively that is actually equal to 2x to the 3 on 2 all over 3. And we've got our value there. So in other words, it's just a matter of now putting that into my calculator. So then that will become 2, and then I have to put 2 to the power of 3 on 2 all over 3. And then because it's 0, it doesn't really matter what I do, it's just going to be 0. So then I have to work that out. So that will be, obviously, on the calculator I can do that. It's probably easier to actually graph that. Alright, so if I graph the square root of x, square root of x, go across and delete that. Put in the square root of x, graph that, and now if I go to my calc, go to number 7 again, go 0, and then 2 is my max. It's going to give me an answer 1.889. That would be pretty good. So 1.89 is my answer to that one there. Third example we're going to do, it's essentially the same as what we've got here before. Well, all we're going to do is do the same thing, but we've now got 3 terms. So the first term is going to become x cubed all over 3. The next one's going to become 2x to the power of 2 all over 2. Take 3x to the power of 1. And because it's a definite integral, I put it into square brackets, 0 to 1. So then that will become, now that 2 will cancel out. So that's going to be 1 cubed all over 3 plus 1 squared. Take 3 times by 1, and then I have to take away from that, basically putting 0 into that. It's going to be 0, isn't it? So it's pointless even trying to actually put the values in there, it's a waste of time. So it's going to give me a third, plus 1, take 3, so that's going to give me 1 and 1/3, take 3, would leave me with negative 1 and 2/3, which you may write also as equal to negative 5 on 3. Now if we graph that function, right, we can actually check out to see what that will look like and why it's got a negative value. So if we go to our calculator, we'll just clear that, so it's x squared plus 2x, take 3, we graph that. You can see it actually goes below the axes there, so therefore if we now do our integral for that, so we go from 0 to 1, sorry, I obviously pressed the wrong button. If we come down to number 7, right, our lower limit is 0, our upper limit is 1, it works out to be negative 1.66, which we can recognise as being negative 5 on 3. Alright, well thank you for listening for that. Now obviously we've got some questions for you to have a go at doing before you come to class. If you'd like to have a start of these are in exercise 6D, and I'd like you to come down to question 2 and have a go at doing a couple of these questions for us. Okay, good luck with those, and make sure you catch up with me in class if you need some help.